So my name is Byun, and that is me a year ago. So this is my presentation on how I got into research. So brief intro. I grew up in Sunnyside, Queens, and it's a great place. Very diverse, a lot of science involved. There's the Museum of Science, and that's what got me into science. That was my favorite subject, and I excelled in it. So I knew I wanted to do something in the sciences early on. But then, and then I, decided to go into air and space because I thought that was cool, and it was just really, it was really like, I don't know, manly, I don't know. But I struggled in math, for most of my life, and it basically kind of hindered my goals from pursuing this more. But I love, planes and machines so much that I just decided to stick to it and overcome this struggle. So then I got into college. I started out as a physics major, but then I moved to mechanical engineering. I decided that I wanted something more hands-on, and that's why I'm in engineering now. So I still struggled in calculus because I didn't really have the best math background. But I persevered, and I started to learn from the professors here at Northeastern, and I worked through it, and then I finally started to get a little good at it. And then that's when things started to turn around. And so then I journeyed into research. So I did my, so when I was looking into co-op, I didn't really want to go into industry first. I knew I wanted to go into research, and I basically did not want to do industry. So I started looking around, and that's when I enrolled in PRISM course, and because they had a bunch of flyers that said you can do research, and it was great. So I did my first co-op at the Action Lab, which a lot of you are familiar with. And that's where I started my research journey. So the Action Lab. So a lot of you may already know this, but basically, the Action Lab studies the interactions between brain and basically human movements. And they try to understand how the body coordinates these movements. So basically, that is more or less what the Action Lab studies. And I got into a field called control systems. And with the Action Lab, I worked with the biological aspect of control systems, specifically with humans. So then now I'm going to explain my research. So basically, in everything, there's some sort of time delay when there's a coordinated movement. When a human grabs a cup of coffee and drinks it, there's some sort of time delay that the body has to deal with when the brain coordinates the movement. So basically, I wanted to go into research something with automated vehicles, unmanned automated vehicles, called UAVs. And there's a time delay associated with that as well. And I wanted to study, so since I wanted to study that, Dagmar Stern, the director of the lab, tasked me with trying to figure out a way on how we can study the time delays in humans and how we coordinate movement, such as dancing, and then later apply that to robotic systems. So at the Action Lab, I did a lot of programming, which is fun, and I programmed that device, which is called a Haptic Master, and that basically creates a virtual environment, and basically you can program, different variables in the environment like gravity and whatnot, and then you can measured the force, distance, velocities of human movements. So that's how we collected data, and we introduced time delays in how the system reacts compared to the motions that the humans input into the system. I also did some programming on that tablet, which Dagmar Skirnet had specific purposes for, and I did a lot of MATLAB data analysis. So, yeah, and I also got to attend lectures and seminars through my research. Basically, I was able to go to a neuroscience conference in San Diego last year, and it was a great time. I got to present. I didn't have anything published, but I did get to talk about some other projects that I worked on in conjunction with the lab members. And I also, yeah, so basically there was a bunch of talks at MIT and BU I participated in, and there was basically something called the Action Club, which discusses papers in the field of human motor control. And yeah, it was great. So, yeah, and I also did some, you know, I did some design work using my mechanical engineering background for some lab equipment at the X Lab. So that all basically gave me sort of a lot of skills and assets that I needed to go into industry. So for my second co-op, which I'm currently on, I decided to do my co-op at Draper Laboratories. And my job title there is a System Integration and Test Engineer. So I basically deal with anything that needs to be tested on and basically put together or whatnot. So we work on the Trident ballistic missile program, and it's basically a big missile that comes out of the submarine and does cool stuff. So yeah, so like I said before, I used a lot of problem-solving skills that I obtained from my research experiences that I need to apply at Draper Laboratories. Basically, you know, with one of the main things I do there is programming, and I write MATLAB programs that simulate and analyze data from guidance systems, and I use my research experience doing the same thing with human subjects, and I apply that to what I do at Draper. I also basically implement some of the same techniques to solve problems. Yeah, I basically said that. And then one of the main differences is that at Draper, I started writing tons of code. When I was doing research, I wrote a couple hundred lines of code. Now I'm writing a couple thousand lines of code. So it's, you know, it's very different, it's very intense, but research is what prepared me for that. I'm also doing some design work. I design test equipment to hold and basically hold and test missile equipment for flash X-ray radiation tests. Basically, they take the guidance system and they flash it with X-rays to see if it'll survive. And I have to design the equipment that houses that so they can test the equipment. And I was given a lot more responsibilities. Basically, they tasked me with buying all the materials and doing all the purchasing, and you know, it's kind of overwhelming when you need to buy $1,000 worth of equipment and you don't know, you know, you can't really say to them, "Oh, I bought the wrong thing." You know, that's not gonna really fly well with them. But so yeah, I do that, and you know, one of the greatest experiences out of this was that I had the chance to work with machinists, and the reason why I value this experience a lot is because you can design the greatest product there is, but there's a certain limitation when it comes to making it. So there are certain things that can be machined that you might not know of, and you know, if you don't take that into account, basically there's a lot of problems that come out of it. So I got to learn firsthand what can be done, what can't be done, and it helped me, basically, it helped me with my design skills. And yeah, so I also got a lot of hands-on experience. I learned how to solder electrical components and use machining equipment. So, advice. So yeah, I might have gone a little fast, but I apologize. So, yeah, so one of the things I would recommend is to apply for research positions early. And there's a lot of research positions available through NSF, through the school, and through government agencies like NASA and the Department of Energy. So I'd recommend that you guys apply to them early. Second, as many of the previous presenters have said, build a relationship with your professors. They'll help you to get recommendations. They'll provide a lot of pathways to research, and it's always good to just build that relationship so that you can sort of get in the field. And third, enroll in the PRISM 1 credit course. That's how I got started, and I think that'll be a good way for you guys to get started. And my last piece of advice is consider pursuing an advanced degree. What I've learned over the years is that basically a bachelor's is starting to become very common. And at companies like Draper or even Fix, at Draper specifically, 45% of the employees at the company have their master's. And I think about 25–30% only have their bachelor's. So they're starting to hire more people with masters because a bachelor's is starting to become very common, and it's not enough for what companies are looking for.